Hello everybody, welcome into another lesson. So today we are going to get into some right triangle trigonometry. And some of this will seem like a review from either Algebra 2 Trig or from Geometry. We covered this a little bit. And if you've never had Trig before, besides a geometry course in high school or something maybe, then this will really be helpful to you. So you're given a right triangle with some angle theta, and you have two of the legs of the right triangle. You're being asked to find the value of the 6 trig functions. Well, we have the 3 foundational ones. You have sine, cosine, and tangent. Your cosecant, secant, and cotangent are simply the reciprocal of those 3. So you see here SOHCAHTOA. Sine stands for the opposite leg over the hypotenuse. Cosine, adjacent leg over hypotenuse. Tangent, opposite leg over adjacent leg. So first thing you want to do though is you have a missing side. You definitely want to find that missing side. So let's call this side B. Well, what can we do to find the missing side? This goes back to Pythagorean theorem. So we know that a squared plus b squared equals c squared. So in this case, 3 squared plus that b squared would equal that 5 squared. Because the 5's your hypotenuse, the side opposite the right angle is always your hypotenuse. So now you have, this would turn into 9 plus b squared equals 25, which is going to end up giving you b squared equals 16. And for length, we only consider the positive square root, so that means b is going to end up being 4. So we found the length of our missing side to be 4. Now that we have all three sides, we can find the 6 trigonometric functions. So let's start with the sine of theta. So the sine of theta, that is simply going to be, of course, your opposite leg from the angle over your hypotenuse. So opposite is 3 over your hypotenuse of 5. So the sine of theta would be 3/5. Now let's find the cosine of theta. The cosine is your adjacent leg to the angle. So your adjacent leg is 4 over your hypotenuse of 5. So the cosine of theta equals 4/5. And then we can find the tangent. The tangent of the angle is the opposite leg over the adjacent leg. So tangent of theta equals then 3 over 4. Alright, now we can find the cosecant of theta, which is the reciprocal of the sine function. Cosecant's the reciprocal of sine, which would be hypotenuse over opposite, or simply just take the reciprocal of 3/5. You would get that the cosecant is 5/3. And then you have the secant of theta, which is the reciprocal of the cosine function. That's the hypotenuse over your adjacent leg, or simply the reciprocal of the cosine. So the reciprocal of 4/5 is 5/4. And then, of course, you have the cotangent of theta, where that is the adjacent leg over the opposite leg, or simply the reciprocal of your tangent. The reciprocal of 3/4 is going to be 4/3. So you have now found the value of all 6 trig functions of this angle. Your sine is 3/5, your cosine is 4/5, your tangent is 3/4, the cosecant is 5/3, the secant is 5/4, and the cotangent is 4/3. And I got plenty more of this. Keep my triangle drawing up here. Alright. So we have another right triangle where we know two of the lengths of the legs. We know the length of one leg and the hypotenuse. We still don't know the length of this other leg. So let's call this length B again. We need to find that before we try to find the value of the trig functions. So use Pythagorean theorem, you would take 5 squared plus b squared equals that hypotenuse squared of 13 squared. So you would end up getting 25 plus b squared equals 169, which would give you that b squared equals 144. And again, since it's a length, we only consider the positive square root, so that means b would equal 12. So now we found the length of the missing side to end up being 12. Alright, now let's proceed to finding the 6 trig functions. So the sine of theta, so that's the opposite over the hypotenuse, so you would get 5 over 13. The cosine of theta, that's the adjacent leg over the hypotenuse, so you would get 12 over 13. Then you want to find the tangent of theta next. That's the opposite over the adjacent leg, so that would be 5/12. Now from here, since we found our 3 foundational functions, you can find the 3 reciprocal functions quite easily. So the cosecant of theta is going to be the reciprocal of the sine. The reciprocal of 5/13 is, well, 13/5. So that would be your cosecant. The reciprocal of the cosine function is the secant function, so we can find the secant of theta. Reciprocal of 12/13 is 13/12. And then we can find the cotangent of theta. That's the reciprocal of the tangent, so the reciprocal of 5/12 is going to be 12/5. So there are the values of your 6 trig functions for this particular triangle. Alright, got a couple more of these, then we'll move on. Let's see what they give us this time. They give us, alright, so they give us both legs, but we don't know the hypotenuse. So we got one leg of the right triangle is 8, the other leg is 15, we don't know the hypotenuse. We'll call that C. So that's going to be C for your hypotenuse. Well, the Pythagorean theorem states that a squared plus b squared equals c squared. So this would end up being 8 squared plus 15 squared equals c squared. This means that 64 plus 225 equals c squared, which would then give you that c squared equals 289. And again, we only consider the positive square root. Square root of 289 is 17. So your hypotenuse has a length of 17. So now we can fill that in since we know what the length of the hypotenuse is. Alright, now we can proceed to finding the 6 trig functions. We'll start with the sine again. So the sine of theta equals the opposite over the hypotenuse, so that would be 8 over 17. Now let's find the cosine of theta. Cosine of theta is the adjacent leg over the hypotenuse, so that would be 15 over 17. And then now let's find the tangent. The tangent of theta would be the opposite leg over the adjacent leg, so that would be 8 over 15. Now that we found the 3 foundational functions, we can find the 3 reciprocal functions. So the reciprocal of sine is your cosecant function. So the cosecant of theta is the reciprocal of 8/17, which would be 17/8. Alright, now the reciprocal of the cosine function is your secant function. That's going to, of course, be the reciprocal 15/17, which would end up being 17/15. And then we can find the cotangent of theta. Well, that's going to be the reciprocal of tangent, so that's reciprocal of 8/15 is 15/8. So there are the 6 values of your trig functions for this triangle. And I got one more of these, then we're going to move on a little bit. All right. Another one with 2 legs. So we got 12, 18, but we don't know the hypotenuse. So we have a leg of length 12, a leg of length 18, but we just don't know the hypotenuse. So we'll call the hypotenuse length C. So apply Pythagorean theorem, you'll end up taking 12 squared plus 18 squared is going to be equal to C squared. So this would give you 144 plus 324 equals C squared. So that means C squared would equal 468. Now, of course, we're only going to consider the positive square root, but what I would like to know is, does 468 break down evenly? I don't think it does, sadly. But there's going to be ways to deal with it, to break it down into a product of roots at least. Alright, so first let's see if it's a perfect square. It's definitely not. Yep, it'll break down into 4 times the square root of 117. So let's see. It'll break down into the square root of 4 times the square root of 117, which means C would equal 2 times the square root of 117. That looks pretty awful, doesn't it? But unfortunately, you will have situations like that. So now that we know the length of our hypotenuse, it's going to be 2 times the square root of 117. We can proceed to finding the value of the 6 trig functions. So the sine of theta, again, equals your opposite side, which would be 12, over your hypotenuse, which is 2 times the square root of 117. Which would initially reduce into 6 divided by the square root of 117. Then if you rationalize this, which you absolutely should, you'll end up getting 6 times the square root of 117 over 117. So your sine's a little bit messy, but the sine ends up being 6 times the square root of 117 over 117. And then we can go for the cosine of theta, which is your adjacent leg of 18 over that hypotenuse of 2 times the square root of 117. Alright, well, this would reduce into 9 over the square root of 117. Now, here's where it gets interesting. If you rationalize the denominator, you'll end up with 9 times the square root of 117 over 117, which we'll come back to sine in a minute, but 9 goes into 117 13 times. So this would really be the square root of 117. Whoops. You really get the square root of 117 over 13. 13. Now, 6 and 117 have 3 in common, so really that should be 2 over 39. So that sine one actually reduce into 2 times the square root of 117 over 39. That would really be the full reduced form. Then your cosine's the square root of 117 over 13. Now we can find the tangent. The tangent of theta is equal to the opposite side over the adjacent side, so that'd be 12 over 18. Both divide by 6 evenly, which would end up giving you 2/3. So your tangent is actually going to be 2/3. Okay. Now, from here we can find our reciprocal functions. The reciprocal of sine is cosecant. In this case, it might not be as easy to take the reciprocal. We also know that the cosecant, since it's the reciprocal of sine, is the hypotenuse over the opposite side. So that initially is going to be 2 times the square root of 117 over 12, which would break down into the square root of 117 over 6. So that saves you all that ugly mess of trying to switch numerator and denominator, then having to rationalize again. Alright, now the reciprocal of cosine is your secant function. Well, here's the thing with that. Your secant function, since it's the reciprocal of cosine, is hypotenuse over adjacent. So that would be 2 times the square root of 117 all over 18. Well, that'll reduce into the square root of 117 over 9. So your secant equals the square root of 117 over 9. Then your tangent, that's fairly easy. I mean, your cotangent, that's easy. That's just the reciprocal of a tangent, or you could say adjacent over opposite, but reciprocal of 2/3 is actually 3/2. So the cotangent of this angle would equal 3/2. So there's the value of your 6 trig functions this time. Alright, now let's do some exercises here where you're already given one trig value, you have to find the other 5. I'll show you what I mean by that. Okay. So they start out giving you, for this right triangle, that your sine of theta equals 5/6. That's all you're given to start with. So what does that mean? You still have to find the other 5 trig functions. Well, the sine of theta is opposite over hypotenuse, right? So 5 over 6, that means your opposite leg is 5. Your hypotenuse has length of 6. Now from there, we need to use Pythagorean theorem to find the length of the missing side. Again, we can call this side B. So this is going to become 5 squared plus B squared equals 6 squared. So you would end up getting 25 plus B squared equals 36. Well, B squared equals 11, which means that B would have to equal the square root of 11. So that's not exactly pretty to work with, but we at least know the length now. So this adjacent leg to the angle has a length of the square root of 11. Alright, from here we can now find the other 5 trig function values. Let's go for cosine. So the cosine of theta, of course, is your adjacent leg, which is going to be the square root of 11 over your hypotenuse of 6. So the cosine of theta equals the square root of 11 over 6. Let's find the tangent of theta. The tangent of theta, that's your opposite leg over your adjacent leg, so that'd be 5 over the square root of 11. which when you rationalize the denominator is actually going to turn into 5 times the square root of 11 over 11. So that would be the tangent of theta would be 5 times the square root of 11 divided by 11. Now let's go for the cosecant function, the reciprocal of sine. Cosecant of theta equals the reciprocal of 5/6, which would actually be 6/5 in this case. Alright, so that wasn't so bad. Now let's find the reciprocal of your cosine, which is the secant function. The secant of theta, that's your hypotenuse over your adjacent leg, so that'd be initially 6 over the square root of 11, but when you rationalize it, you would actually get 6 times the square root of 11 all over 11. That would be your secant. And then last but not least, you have your cotangent of theta. Now again, you already have a radical in the numerator. As opposed to just taking the reciprocal and rationalizing, it might be easier to use the fact that cotangent is adjacent over opposite, which would give you a nice clean square root of 11 all over 5. You would come to that anyway if you switch places with numerator and denominator, but it's going to take you more work to get there. So these are the values of your 6 trig functions this time. Alright, let's do 5 more of these. So you're given that the cotangent of theta equals 5. That's all you're given to start with. They give you nothing else. The cotangent of theta equals 5. Well, cotangent is your adjacent leg over your opposite. 5 is the same as 5 over 1, so your adjacent is 5, your opposite is 1. So you have the length of both legs. What we don't know is the length of the hypotenuse, so we'll just call that C. And of course, we're going to perform Pythagorean theorem. So that means that 1 squared plus 5 squared equals C squared. So that means that 1 plus 25 equals C squared. So then you'll just get that C squared equals 26. So C equals the square root of 26. So you have a not very nice hypotenuse with a length of the square root of 26. Alright, now we can find the value of the other 5 trig functions. Well, it might be easy, since we have cotangent, we can go right to tangent. Let's just do tangent of theta first. We know that's just the reciprocal of the cotangent, right? So the reciprocal of 5 is 1/5. So the tangent of this angle would be 1/5. That's easy enough. Let's get into the other 4 functions. So let's take the sine. The sine of theta is the opposite leg over the hypotenuse. So that of course would equal 1 over the square root of 26, which is going to rationalize into the square root of 26 all over 26. That would be your sine. Let's go for the cosine of theta. Cosine of theta is your adjacent leg over your hypotenuse, so that would be 5 over the square root of 26, which is actually going to rationalize into 5 times the square root of 26 all over 26. So all that's left now are going to be your cosecant and secant functions. So let's take the cosecant of theta. And since we have a radical in the numerator, it might be easier to just use the idea that the cosecant of the angle is the hypotenuse over the opposite side. So you would get the square root of 26 over 1, or simply just the square root of 26. That might be the easiest way to do that one. Now let's take the secant of theta, which of course is the reciprocal of the cosine. And since you have a radical in the numerator, again, it might be easier just to use the fact that the secant of the angle is the hypotenuse over the adjacent leg. So you would get the square root of 26 over 5 as your secant. So those are your other trig values for this particular triangle. All right. What do we get this time? So this time we're given that the secant of theta equals 4. That's all they give you to start with, is that the secant of theta equals 4. So what is the secant of the angle? That's always the adjacent leg, that's the hypotenuse over your adjacent leg. So if it's 4, that's 4 over 1. That means your hypotenuse has length of 4, your adjacent leg has length of 1. So now we need to use Pythagorean theorem to find the missing side. We'll call that A this time. We're going to find that missing side A. So this would turn into A squared plus 1 squared equals 4 squared, which would then end up giving you A squared plus 1 equals 16. So then you would get that A squared equals 15, and then you would simply get that A equals the square root of 15. And that's the best we could do with that. So the missing side is now the square root of 15. Okay. So we have the secant, we have all the missing sides, let's find the other values. Since we're given the secant, it might be easiest to go right for the cosine, because the cosine's the reciprocal of the secant, so the reciprocal of 4 is 1/4. So the cosine of theta is going to be 1/4. Alright, now what about the sine? So the sine of theta is the opposite leg over the hypotenuse. That would be the square root of 15 over 4. Okay, now let's go for tangent. Yeah, let's go for actually the tangent now. The tangent is the opposite leg over the adjacent leg. So that would be the square root of 15 over 1, or simply just the square root of 15. So your tangent is the square root of 15. All right, we got secant, cosine, sine, and tangent. Let's go for cosecant next. So the cosecant of the angle, of course, is the hypotenuse over the opposite. So that's going to be 4 over the square root of 15, which when you rationalize this will turn into 4 times the square root of 15 all over 15. That would be your cosecant of theta. And then we can find the cotangent of theta by taking the reciprocal of the square root of 15, which initially would start out as 1 over the square root of 15. But if you rationalize it, you end up getting the square root of 15 all over 15. And that would be your cotangent of theta. So those are all 6 trig function values for this particular triangle. I should have 3 more of these. All right. So we're given that this time that the cosine of theta, so the cosine of theta equals 3/7. That's what we've been given. That's all they give us. The cosine of theta equals 3/7. Cosine of an angle is always the adjacent leg over the hypotenuse. So your adjacent leg is 3, your hypotenuse is 7. We don't know the length of the missing leg. We'll call that leg A. So once again, let's go ahead and use Pythagorean theorem. So this would be a squared plus 3 squared equals 7 squared. So a squared plus 9 equals 49. So that means that a squared equals 40. Well, 40 breaks down into 4 times 10, so that means that a would end up equaling 2 times the square root of 10. So that's really not a very pretty one at all. So that means that a is going to have a length of 2 times the square root of 10. Alright, so now we're ready to proceed with the other angles. Since they gave us the cosine, it might be easiest to try to find the secant, which is the reciprocal of that. The reciprocal of 3/7 is going to be 7/3. So the secant of theta would be 7/3. Okay. From here we could go anywhere. So what about the sine of theta? That's always going to be your opposite leg over your hypotenuse. So in this case, the sine of theta is going to equal 2 times the square root of 10 all over 7. So there's your sine. Let's find the tangent. The tangent of theta is your opposite leg over your adjacent leg. So that would be 2 times the square root of 10 all over 3. That would be your tangent. Alright, let's find the cosecant. That's just the reciprocal of the sine, so that's going to be the hypotenuse over the opposite leg, so that would be 7 over 2 times the square root of 10. Well, we need to rationalize this, so let's do that. What you really end up getting for the cosecant is 7 times the square root of 10 all over 20. So that was not a pretty one to get whatsoever. And then now, of course, let's find the cotangent. So the cotangent of theta, that's your adjacent leg over opposite. So this is going to be 3 all over 2 times the square root of 10. But we need to rationalize this again. So square root of 10 over square root of 10. This is going to turn into 3 times the square root of 10 all over 20. That would end up being the cotangent of this particular function, of this particular angle. So there's all the values of your angles. Alright, let's see, I have 2 more. So we have, this time, they just give you that the tangent of theta equals 3. All they give you is that the tangent of theta equals 3. You don't know anything else. Well, the tangent of theta is the opposite leg over the adjacent leg. So that would be the same as 3 over 1. So your opposite leg is 3, your adjacent leg is 1. What we don't know this time is the hypotenuse. So let's go ahead and look for that. We'll call this leg C, the hypotenuse. So that means then that 3 squared plus 1 squared equals C squared. So that would mean 9 plus 1 equals C squared. Well, that's going to go to C squared equals 10. So c would have to equal the square root of 10. So your hypotenuse is actually going to have the length of the square root of 10. Alright, now that we know the value of all of our sides and we know one trig function, let's find the other 5. Since they gave us the tangent, we could probably pretty easily solve for the cotangent of theta. Since it's just the reciprocal, well, the reciprocal of 3 is going to be 1/3. So the cotangent of theta is 1/3. Now let's go for the sine of theta. The sine of theta, that of course is your opposite leg over your hypotenuse, which initially begins as 3 over the square root of 10. When you rationalize it, you'll get 3 times the square root of 10 divided by 10. That would be your sine of theta. Let's find the cosine of theta. That is your adjacent leg over the hypotenuse, so that would initially start out as 1 divided by the square root of 10, which when you rationalize this, you'll end up getting the square root of 10 divided by 10 for your cosine. So we got tangent, cotangent, sine, cosine. Next we need to find cosecant and secant. So the cosecant of theta, well, that's your hypotenuse over your opposite leg. That would just be the square root of 10 over 3. That's going to end up being your cosecant. And then, of course, if you want to find your secant of theta, that is your hypotenuse over your adjacent leg. Square root of 10 over 1 is simply just the square root of 10. So those are the values of the other 5 trig functions you're looking for. I got one more, and then we're going to move on to one final part of the lesson. Okay, so you're given, all they give you is that the cosecant of theta equals 17/4. That's all you're given. The cosecant of theta equals 17/4. Okay, so what is the cosecant? That's your hypotenuse over your opposite leg. So the hypotenuse is 17, your opposite leg is 4. Well, we don't have a clue what the other leg is. We'll call that length B. So let's call this B. We can solve for that by using Pythagorean theorem. So this would be 4 squared plus B squared equals 17 squared. So that would give you 16 plus B squared equals 289. So B squared would equal 273, and the bad news is I don't know if 273 breaks down at all. We might literally be stuck with the square root of 273. I hope not, but it's not looking good. We're stuck with it, unfortunately. It doesn't break down any further. So we got this awful value for leg B equal to the square root of 273. So there is our missing leg. It's the square root of 273 for the length. So this one's going to be a real joy to try to do some of these with. Okay. So we're given the cosecant, so that means we could pretty easily find the sine of theta because that's just the reciprocal of the cosecant. So since it's the reciprocal, that means the sine would end up being 4/17. So that one's not so bad. Okay, now what about, let's see, we did cosecant and sine, let's do cosine. So the cosine of the angle is the adjacent leg over the hypotenuse, so that's going to end up being the square root of 273 all over 17. There, in fact, is going to be your cosine. Alright, let's find the tangent. This is not going to be pretty. So the tangent of theta, well, that of course is going to be your opposite leg over your adjacent leg. So this would initially start out as 4 divided by the square root of 273. But if you rationalize that, you'll end up getting 4 times the square root of 273 all over 273. So yes, not a very pretty number. Let's go for the cotangent of theta. So the cotangent, that's just your adjacent leg over the opposite, so that would just give you the square root of 273 divided by 4. And last but not least, let's go for the secant. So that means the secant of the angle is going to be the hypotenuse over the adjacent leg, so that would be 17 over the square root of 273, which would turn into 17 times the square root of 273 all over 273. But what I have to determine, I don't remember if 273 and 17 factor. So 273 divided by 17, nope, no such luck. So that's your answer. This is going to be your answer then. Your secant equals 17 times the square root of 273 all over 273. Alright, so I want to do one more set of problems, which won't be that long actually. In fact, it's going to be quite simple. We won't even have to use Pythagorean theorem for these, and we can find the length of missing sides. So, what am I referring to here? I am talking about a 30, 60, 90 right triangle. We did touch base on this yesterday, but these are going to come up again. Well, in this case, they give you that this leg is 105. They want you to find the lengths of legs Y and R. So you have a 30, 60, 90 right triangle, but you only know one leg. And it happens to be the side opposite the 60-degree angle. Well, what do we know about the 30-degree angle? That the side opposite the 30-degree angle is its normal length, so that means the side opposite the 60-degree angle is the square root of 3 times as long as the side opposite the 30-degree angle. So in other words, that means that y times the square root of 3 would equal that 105, right? Okay, so what does that mean then? That means that y equals 105 all over the square root of 3. But we got to rationalize numerator and denominator, which would end up giving you 105 times the square root of 3 all over 3. Well, this would break down into just 35 times the square root of 3. So that means that y has a length of 35 times the square root of 3. That would be your length for y. And that's opposite. Now, let's I'm going to put that in a different color since we solved for it. So that y, which is opposite the 30-degree angle, is 35 times the square root of 3. Now, what's true for that hypotenuse r? That means the hypotenuse in a 30, 60, 90 right triangle is twice as long as the side opposite the 30-degree angle. So that means that r equals 2 times that 35 times the square root of 3, which means that r would simply be 70 times the square root of 3. So those would be your lengths for y and r. I got more of these. Is it the same type of triangle? Yes, it is. Okay, so we have x, y, and 15. So we have another 30, 60, 90 right triangle. However, we don't know the length of, we know the length of the hypotenuse, we don't know the length of either leg. This will actually be easier because in relation to the hypotenuse, and the shortest leg, the shorter leg, which is opposite the 30-degree angle, what's true? That the hypotenuse is twice as long as the shorter leg. It's twice as long as the side opposite the 30-degree angle. So that means that 2 times y equals that 15, which means what? That y would equal 15 halves or 17 halves. Or 7 halves, excuse me. It would be 15 halves or 7.5 would be your length for y. Let me put that in green since we solved for it. Now, we can find x because that's opposite the 60-degree angle. What's true for the side opposite the 60-degree angle? It's the square root of 3 times as long as the shorter leg from the 30-degree angle. I wanted to write that as 15 over 2. There we go. Okay, so that means then that x is going to equal that 15 all over 2 times the square root of 3, which would just give you 15 times the square root of 3 all over 2. And that would be your x. Okay. So this has a length of 16. Whoops. $60 is your y, so the side opposite is x. Okay, so we have another right triangle, another 30, 60, 90 right triangle, in which again we know the hypotenuse, but we don't know the length of the leg opposite the 30-degree angle or the leg opposite the 60-degree angle. Well, again, the hypotenuse is always twice as long as the leg opposite the 30-degree angle, right? So that means 2 times x would equal that 16, which means that x would just have to have a length of 8. So that one wasn't so bad. So let me put that in green since we solved for it. So x would have a length of 8. And then now the side opposite the 60-degree angle is the square root of 3 times as large as the side opposite the leg of the 30-degree angle. So that means that y is literally going to be equal to that 8 times the square root of 3. So that would be your length for y. It's going to be 8 times the square root of 3. Let's see, I should have one more of this type, then I should have a few of the 45, 45, 90 type, which in my opinion are actually easier. sorry, so side opposite 60 is 38. Side opposite 30 is x, and then this is r. Okay. So we have another 30, 60, 90 right triangle in which the side opposite the 60 is 38. We don't know the side opposite 30 or the hypotenuse. Well, in order to be able to solve for the hypotenuse, we need to find the length of the shorter leg opposite the 30-degree angle, right? So what is true between the shorter leg and the longer leg in a 30, 60, 90 right triangle? That means that the leg opposite the 60 is the square root of 3 times as large as the leg opposite the 30. So that means that x times the square root of 3 equals 38. Which would mean x would equal 38 divided by the square root of 3. So in short, you'll get that x has a length of 38 times the square root of 3 all over 3. So there's your x. It's 38 times the square root of 3 all over 3. So let me put that in green ink since we solved for it. All right. Now, what can we say about the hypotenuse then? The hypotenuse is going to be twice as long as the shorter leg, twice as long as the 30-degree angle leg. So that r is going to equal 2 times that 38 times the square root of 3 all over 3, which then means that r would have a length of 76 times the square root of 3 all over 3. So that would be the length of your r, in this case, your hypotenuse. All right, let's do 4 more, but this time we're switching our triangle type. It's actually going to be easier. The only other special triangle is another one we all should be familiar with at this point also, called the 45, 45, 90 right triangle. So we have a 45, 45, 90 right triangle. We are given, in this case, that the side opposite one 45-degree angle is 20. The side opposite the other 45-degree angle is x, and the hypotenuse has a length of r. We need to find the other leg and the hypotenuse. Okay, so what's true in a 45, 45, 90 right triangle? Well, that means that the side opposite the other 45-degree angle is congruent to the side opposite the first 45-degree angle. So in this case, you're literally just going to get that x equals 20. It's that easy. X would equal 20. So that one wasn't so bad. Now, what's true about the hypotenuse in a 45, 45, 90 right triangle? That it's the square root of 2 times as long as one of the legs. So that means that r is literally going to be 20 times the square root of 2 for the answer. So r would be 20 times the square root of 2. All right, 3 more of these, then we'll be done. They give you that this side's 10, this side's y, and then this side's r. So another 45, 45, 90 right triangle in which you know one leg across from the 45-degree angle, you don't know the other leg yet, you don't know the hypotenuse. Well, again, in a 45, 45, 90 right triangle, the 2 legs opposite the 45-degree angles are congruent to each other. So that means that y would also equal 10. And then the hypotenuse in a 45, 45, 90 right triangle is the square root of 2 times as long as one of the legs. So you would get that r equals 10 times the square root of 2. That would be easy enough. And 2 more of these. let's see. Let's change it a bit. So this time you don't know, you only know the length of the hypotenuse, you don't know the length of the legs. Well, what's true about the hypotenuse of a 45, 45, 90 right triangle? That it's the square root of 2 times as long as one of the legs. So that means, since the two legs are congruent, that means if you solve for one, you can simply solve for the other. So that means that x times the square root of 2 would equal 16. So x would equal the square root of 16, square root of 16, yikes. 16 over the square root of 2, then rationalize, so times the square root of 2 over the square root of 2. Well, that's going to equal 16 times the square root of 2 over 2, which means then that x is going to have a length of 8 times the square root of 2. Which means in a 45, 45, 90 right triangle, the x and y would be congruent. So y also equals 8 times the square root of 2. That wasn't so bad. I got one more, then we're done. Now this one's almost diabolical because the hypotenuse has a length of 2 times the square root of 5. We don't have a clue what the two legs are, but we do know the hypotenuse again is the square root of 2 times as long as one of the legs. So that means that x times the square root of 2 is going to equal 2 times the square root of 5. So x would equal 2 times the square root of 5 divided by the square root of 2. Now let's rationalize. You would end up with 2 times the square root of 10 all over 2, which just means that x would be a length of the square root of 10. So x has a length of the square root of 10, and in the 45, 45, 90 right triangle, the other leg would be congruent, so y also would have a length of the square root of 10. So that one actually wasn't quite as bad as it looked. So that's going to be it for this lesson. Next lesson, we're going to get into a bit of some very rudimentary basic trig identities, which are going to help us in upcoming lessons. So I hope everyone has a great day. Take care.